Good evening and welcome to the BS and Beer Show. BS stands for Building Science, of course. Tonight's topic is our first BS and Beer book club with guests author Bruce King and Chris Magwood. My name is Mike Maines. I am drinking tonight a Brightside IPA from Lone Pine Brewing in Portland, Maine, one of my favorite breweries, a delicious IPA. And tonight we are doing BS and Beer in conjunction with NESI, the Northeast Sustainable Energy Association's Building Energy New York City Conference. And we'd like to give a special welcome to anybody coming in through the NESI door. Welcome. At BS and Beer, we started as a local discussion group, and we strongly encourage local discussion groups. Feel free to use the name BS and Beer or any derivative. A lot of building science is universal, but a lot of it is really more appropriate for local discussion groups, and it's a great way to build networks. I'd also like to thank our media partners, Green Building Advisor and Fine Home Building Magazine. And I will turn it over to Kylie to talk about the mechanics of tonight's show.
Hello, everybody. I'm Kylie Jacques. I'm a senior editor at GBA, and I'm drinking a sparkling cherry lime tree water, which is a byproduct of the sugar maple tapping process. It seemed appropriate for the season. And Emily is going to give us some announcements.
All right, guys. Hey, Emily Macho. I'm an architect here in Maine. Tonight I'm drinking an Island Dog Brewing IPA, so that's exciting. It was a little chilly. I turned the heat up so I could drink beer. Otherwise, I would have moved on to wine, but it's BS and Beer. Couple of announcements tonight. The Fine Home Building Summit is coming up October 26th through the 29th. The Passive House Maine Fall Forum is October 21st through the 23rd. And if you enjoy this show, there are a couple of others out there. We want to highlight the Passive House Accelerator's Global Happy Hour on Wednesday evenings and the BS Fridays with Dave Cooper and Mark Willey. I will put links to those in the chat box. Again, make sure that you pick all panelists and all attendees when you're posting in the chat box so that everybody can see it. And that's off to you to introduce our guests tonight, Travis.
Yes, my pleasure. I'm Travis Brungart, and I'm drinking Bob's 47, great local brewery, Boulevard, here in Kansas City. I saw Nathan B. in the chat calling out Martin City, but I'm representing Boulevard tonight. I'm going to introduce our wonderful guests. We have the pleasure of hosting the author Bruce King, the founder of EBNet, the Environmental Building Network, and a registered engineer with 35 years of worldwide experience in structural engineering and construction. He's the author of Buildings of Earth and Straw, Making Better Concrete, Design of Straw Bale Buildings, ASTM International E-2392, which I'm sure is why everyone tuned in tonight. You get a lot of credit for that one, right, Bruce? That's the chief production, right?
In a way, it actually is.
That's awesome. It's the title does not do it justice. Then, Earth and Building Guidelines. It's the
International Earth and Building Standard, which there was none before.
Well, then I withdraw my comment. My mistake. Earth and Building Guidelines and dozens of papers and articles for conferences and journals. He has organized 3 international conferences on ecological building and is the founder of BuildWall Source, a user-based collection of low-carbon materials and knowledge, and of the BuildWell Symposia. We also have Chris Magwood, fellow author, who is obsessed with making the best, most energy-efficient, carbon-sequestering, beautiful, and inspiring buildings without wrecking the whole damn planet in that attempt. Chris is the executive director of the Endeavor Center, a not-for-profit sustainable building school in Peterborough, Ontario. He has authored numerous books on sustainable building, including Essential Hempcrete Construction in 2016, Making Better Buildings in 2014, More Straw Bale Building in 2005, and in 1998 he co-founded Camel's Back Construction, and over a period of 8 years helped to design and build more than 30 homes and commercial buildings, mostly with straw bales and often with renewable energy systems. Thanks for joining us, gentlemen. Feel free to go ahead and add wonderful things about yourself that I did not mention in your brief introductions. What are you drinking, Bruce? What's going on? You're first. What's to drink tonight?
It's 3 in the afternoon over here on the left coast. But in 3 hours, I will be drinking a vodka martini.
I hope it's delicious. How about you, Chris? What's on the menu?
I thought I would endorse a Canadian stereotype and swig some maple syrup right out of the bottle, which might seem like a joke, but I actually do it almost daily. So I figured this is actually what I drink, so I'm going to drink it.
That's awesome.
That is very Canadian. Impressive.
Good.
All right. Well, I'm going to do just a brief presentation and screen share just to give a quick introduction. If Kylie or Emily, if you can give me permissions, and then Bruce and Chris have some slides as well. So we'll see what makes sense after they see what I have.
You should be able to share now.
Okay.
Okay, thanks. I don't have that.
Maybe while we're waiting, I would love to give a shout out to, since this is a NESI sponsored thing, I got introduced to the NESI community a few years ago, and it's been a real treat to continuously meet people and be involved in NESI related things. So thanks to everybody at NESI for all you do.
And I'll second that. But I have to register my pet peeve. If anybody from NESI is listening, you send out a lot of emails, but you don't give them means for unsubscribing, which is against the law, NESI.
Oh. Well, Chris had a good segue for me because it's appropriate for me that tonight's episode of the BS and Beer Show is in conjunction with NESI. Because it was actually at NESI's Boston conference in the spring of it was either 2017 or 2018, where Chris presented with Ace McCarlton and Jacob Diva-Rakusin on the topic of embodied carbon. And although it was just a few years ago, at the time I really didn't know that much about embodied carbon. I knew it was a thing, I knew it was important, but I didn't really fully understand its impact when it comes to designing and constructing buildings. And I don't think I was the only one in that position. Chris, Ace, and Jacob presented to a packed room. I would guess maybe 200 people of some of the most progressive builders, architects, and engineers in the Northeast and from around the country. And roughly 20 minutes in, they showed a slide that really rocked the world, I think, of a lot of people in the room. I felt that kind of paradigm shift before when the Challenger shuttle exploded, when the fall of the Berlin Wall, 9/11. It sounds like hyperbole, but it's really that sort of experience. Chris talked about his research and education on embodied carbon, and he talked about Bruce's book, which is where I first heard about it. I think a lot of people in that room rushed out to buy it. And Chris contributed to the book as well. Since then, I've seen Chris, Ace, and Jacob do various variations on that presentation. I've presented my own version a few times, and every time when we get to the embodied carbon section, you can really see that it impacts people. So this is sort of my quick version. These are slides from the Fine Home Building Summit last year, which was one of the times I presented it. This is a chart probably everybody in the audience has already seen, but it shows, for all global warming emissions, building operations contribute a lot, building materials and construction contribute a lot, together about 40%. Then this is my interpretation of a chart from Bruce's book that shows embodied carbon emissions, operating carbon emissions, shows over the course of 100 years, which is what global warming potential is usually measured on. Operating carbon dwarfs embodied carbon emissions, but we don't have 100 years if the scientists are correct, and scientists are usually correct. We have 20 years, maybe 10 years, and on that time frame, embodied carbon really matters. So again, the gray slice is very important, and a lot of what Bruce's book is about. These are the slides from Bruce's book. He may show them as well, a little more detail about what this really means and the impacts of building high performance or renovating, retrofitting. There's a few other slides from the book that I think are worth noting. One is the challenge of measuring embodied carbon accurately. These are various data sources for wood, the embodied carbon in wood, so it can be hard to really get precise values, which can be a challenge. This is a graph that shows the initial carbon input of planting something, but then the deep carbon storing ability over time that those materials have. So clearly, embodied carbon matters. What do we do about it? The book covers a range of potential solutions, including chapters on minimizing how much we build, using materials such as wood and straw that are or can be at least carbon sinks. It also includes chapters on ways to reduce the impact of concrete and plastics, using technology, how building codes might help us get where we need to go if we are to continue with life as we know it. So that is my brief overview of the book. I assume everybody here has read it, but just in case you haven't, that's sort of a very quick overview of what I think are the important parts. Bruce or Chris, do you want to add or continue that, or what do you guys?
I have a few slides that I can go through in about 60 seconds to give the idea for the book that Chris and I are now working on, and sort of the kicking point. And I don't know, there's a lot of people here. This is really exciting, and I don't want to take it up with showing a bunch of slides. Chris has some too, and we could overwhelm you with a bunch of information. But maybe it would be better just quick few slides that build on what Michael just showed, and then leave it open to questions, which is, to me, the fun part. So if you want to give me the screen, I'll do so. And
you're going to have to do it, Emily. I don't have that control today.
Let us know.
You should have access to it. There's a green button on the bottom of the screen, Bruce, and you should be able to hit share screen.
Chris and I are at work right now on a book nominally titled Beyond Zero, and it's the sequence, the follow-up to the new carbon architecture, and builds on the ideas that Michael just described. The green building movement started with energy efficiency a couple decades ago, 3 decades ago. Then net zero became what everybody was talking about, and it's great. It's all good stuff, but we recognize this very optimistic and positive possibility of beyond zero, meaning buildings that actually store more carbon than they ever emit. There's some technological hurdles, but there's more cultural, as usual, there's more cultural hurdles than technological ones to that. But that's what it is. Carbon storing architecture to cool the planet. We're at work on it. We hope to have it out next year. Who knows? It's hard to function with. So you guys are mostly on the East Coast, and you only have a pandemic and climate change and a collapsing democracy to think about. I also have fires and smoke all the time. It's getting to be a bit much, not to complain or anything. But here's the idea. We live in this it's not a biosphere, it's a bioshell. If you collapsed all our atmosphere, it would be a sphere that big. It's really small. The usable, breathable atmosphere only goes 5, 6, 7 miles over your head. That's the distance to think of whatever the 5-mile-away town is from you. That's how thick it is. It's just paper thin. That's what we're messing with. That's what we have to fix. And in the history of humanity on Earth, as our species evolved over the last 500,000 years or so, atmospheric CO2, you've seen all this stuff before. It was bouncing around between 200, 300 parts per million. And now here in the late industrial revolution, we're well over 400. And it's a big problem. If we were to stop right now burning fossil fuels, if somehow we just stopped tomorrow burning any fossil fuels, the graph would still be going up, and I don't think you can see the arrow going off to the right. Kylie, can you get out of the way there? Can you scooch over to your left a little bit? I think you get the idea. Even if we stop burning fossil fuels, it's not enough. The IPCC says so. We have to bring it down. We have to draw the carbon down. And that begs the question, how do we get it out of the air, and then where do we put it? We already are pulling some out, but right now what we do is pull carbon out of the air, and oil companies use it, turn it into gas or liquid, and inject it to the ground so that they can get more gas and oil out of their oil fields. And we pay carbon taxes to do that. Doesn't seem like a great plan to me, but that's what we're doing right now. If we wanted to have a safer and better repository, well, the best one is probably soil. And there's all sorts of people doing all sorts of really great work in that regard. And buildings, because buildings are by far the biggest human constructions on the planet. We use more physical stuff than anybody does. And we're building a lot. The equivalent of another New York City every month, mostly in China and India. We don't see it here because we're not building anything like that here. This isn't where the action is. So there you go. That's the end of my show. And I'll stop my share. And I can leave it at that. So Chris and I are building on that. Chris has done some fantastic work, his master's thesis up at Trent University, and we both got a lot of balls up in the air working with all sorts of people. It's really exciting. There's a lot happening in this realm now. And we're frantically trying to write the book as fast as we can, and it'll still be obsolete by the time we get it out the door, but it's the nature of things these days. I'll leave it at that. We could start taking questions now, or Chris, did you want to say something, or?
No, I mean, I'm happy to just get into the discussion. I think, you know, the thing to me that is really interesting about the book, you know, I think Bruce and I sort of function in this narrow world where you know, the idea that this is a reasonable thing to be thinking about. And you know, the more that I work on this, and you know, we've been talking to a lot of people about the book, and a lot of people who are sort of leaders in climate change and buildings and stuff, and even in that realm, the notion that we can stuff enough, practically even stuff enough biological material, biomass into buildings, it's sort of this crazy new idea, but it also, you know, has this great sort of precedent. There's been people doing it for a long time, and the notion is sort of out there, and it just feels really exciting to be at this point where, you know, the thing that the kooks have been doing for the last 30 years suddenly turns out to be the thing that we all need to do, and it's really, you know, fun to be at this point where, oh yeah, okay, like, you know, it turns out the bamboo builders and the straw bale builders and the earthen builders, like, they had the right idea and they were going down the right path, and you know, it's really fun to be in a place where that now becomes part of this discussion about, like, how do we actually rescue the climate. And it's certainly not the only thing that needs doing, you know, but in the realm that we're all in the building realm, it's kind of, you know, to me, what's exciting is that a lot of other sectors are facing this, you know, complete crisis of their sector may not even exist, you know, in 20 years. Whereas with builders, it's like, no, we actually will keep building things. And if we do it right, you know, the buildings we build, like, we become the climate heroes. Like, there's this possibility that just by doing what we already do and what we're already smart enough and practiced enough and skilled enough to do, if we do it right, you know, we end up doing the right thing while keeping busy and working and making money and, you know, housing people and doing all this really important stuff. Like, we can kind of keep doing that and have this, you know, incredible potential impact on the climate.
That's what I was so excited about with this book. When I heard about the book through Mike at the Fine Home Building Summit last year. He introduced me to this, and as a builder, I have long been part of the problem, and of course was extremely disturbed to learn about this news that I probably should have already been well aware of, but I'm a little late to the party. So in reading the book, that was, and exactly what you're saying, Chris, it's an opportunity. Like, there was a real hope that welled up in me after getting through the book at all the options that you laid out for potential paths to success here. And I was so grateful to, you know, start out with this incredible depressing vision of, oh, look at this disaster that I've contributed to, and then to turn the page and be like, oh, and here are the 20 ways that I could actually be part of the solution here. It's really a unique opportunity, and I'm really grateful for the work that you did to put this together, to share these ideas with people like me that are, we're in a position to really do some good.
Yeah, absolutely.
Yeah, it's exciting. And, you know, the thing that I also find really exciting is it's not even that hard. You know, the things that we've already done in the building.
Oh, you're freezing up, Chris.
To create create a cement industry, or to create, insulation out of oil with bubbles blown in it. Those are remarkable, things to be able to do. And the only thing that we really need to do now is take various kinds of fiber and smush them together, glue them together, stretch them out, bond them, whatever the material and the process happens to be. They're easy things to do for, a business that's or a sector that's has been as creative and innovative as the building world.
Yeah. So one comment reminded me of basically, what about China and India? With them growing exponentially, why should we even bother? That's a response I hear a lot, and I know that I have some answers. But what do you guys say about why should we be trying when China and India are doing so much construction right now?
If the ship hit an iceberg and you have a chance to either patch it or bail the ship, even if you think you only have a 1 out of 100 chance, you're going to fucking bail. That's your job.
I would also say yes.
And to follow on what Chris said too, because Chris is appropriately very focused on plant-based architecture, and it's appropriate to you who are mostly in New England, I guess, because you can build with sustainably harvested wood and with straw insulation and straw bales and so on, which is all great. I traveled to Egypt a year ago and toured Cairo, which is I think a somewhat typical new mega city. It's gone from 5 million people to 25 million people in 20 years. And it was jaw-dropping for many reasons, besides seeing the pyramids, which is jaw-dropping, but there wasn't any wood. They're not going to build out of wood. And everything was concrete and fired brick. I didn't even see a shred of insulation of any type anywhere on a truck, in a building, anything. Just concrete buildings with window-mounted air conditioners for people who could afford those and had some power in the building. That's what's happening in China. That's what's happening in a lot of India. It's all concrete. So a lot of the focus of our new book, just like the last one, is about mineral architecture. How do we reinvent concrete? Concrete is artificial rock. You take some sand and gravel and glue them together into some shape and color and thing that can hold up a roof or can be a sidewalk. And you don't do that with straw. And oftentimes you can't do that with Adobe either. So we have to have better forms of concrete. And in fact, as part of the research Chris and I are doing, we're hosting these panel sessions, online Zoom panel sessions with the experts in relative areas. And Monday morning we'll be doing concrete. It's not open. It's just for the people who can do it. It'll be recorded and then made available. But one of the people I asked, Karen Scrivener, is a professor in Switzerland, and I've worked with her a bit over the years. One of the most knowledgeable people about concrete and the concrete industry that I know. Just a very impressive woman and very Swiss, very proper and Swiss. And when I wrote to her about this book we're doing about the notion of buildings storing more carbon than they have, she's thinking of concrete. She says, well, you can't do that. We can try to get it down to zero, but you can't do that. To which I countered, well, if you put a price on carbon, let's say there was a 100 billion euro prize for the person who can develop carbon storing concrete, we would have it within a generation.
Right.
Easy. Because we're human beings and we are really inventive, and that's what we would do. But the money's not there, so we're not doing that. So a lot of it has to do with, to the China and India question, they're building with concrete. Africa is building mostly with concrete. There's a lot of parts of the world where building with wood is just not an answer. And even building with wood in North America and Europe and such places, of course, is not quite so simple, because you want to make sure it's from sustainably managed wood, which is not a simple issue. The simple takeaway is use FSC certified lumber. Past that, it gets really complicated. And we'll be having a lot about that we did in the old book, and we will in the new book. I think I'll leave it at that with China and India. And by the way, people are putting all sorts of stuff in the chat thing, and I can't keep up with it, so I'm not going to try to.
I do just want to say about China and India, though, as I research, who's doing really interesting work on biologically based building materials. There's a ton of stuff going on. Like if I want to buy pressed straw board, it's being made in bulk in China. If I want to buy rice board, it's being made in bulk in China. If I want, there's bamboo products. I mean, those countries are in some ways kind of kicking our butts in terms of how they're working with egg materials and turning them into building products. I wish I had access to half of what I see being made in China in terms of agricultural building products. So, it's not like they're doing nothing. I'm not sure that they're seeing it that it's being tied to the climate. I think they're just seeing it as they just don't let that stuff go to waste. If you can make something out of it and you can put a factory together, which seems to be a lot easier to do in Asia than it is here, somebody will take somebody else's stuff and turn it into something that they can sell to somebody. I think that sort of spirit is, it's kind of sorely lacking here. We would just let the stuff sit out in the field and rot instead of, figure out how to make something out of it. So I think, they're not without the potential in those places to, really change what they're doing. And in some ways they're sort of further along the path, even if it's not an intentional path to working with those bio-based materials more.
Not everybody has wood, but everybody has straw because everybody grows food. And so one of the bottlenecks, and we'll be writing about this too, is finding a glue. I'll be talking to John Warner of Green Chemistry and other people, and there's some promising things happening there. If we could just find a robust family of glues that are, not horribly toxic and perform the way we want them to, then we could take all this agricultural waste, primarily cereal grain straw, and turn it into plywood and insulation and who knows what. Again, if the money were there, we'd develop all this stuff in a flash.
That's the sweet spot right there. As a realist, often accused of being a pessimist, I feel like this is the time to seize the opportunity created by our tremendous hike in lumber prices. It's all of a sudden very interesting to builders to learn about plywood made of straw, since my sheet goods are up 300% in the last 2 weeks. Seize this market opportunity. If you're the producer of this material, get it to market. Let us know where we can get it, and we're going to start ordering it now.
Yeah, and one of the sort of sad things is that in North America, those products have gone numerous times. They're straw sheet panel factories. There have been compressed straw board factories. There's been, and I mean, the rice, Cal plant is now doing the rice straw MDF thing. They're going to be going back, not back into production soon. But a whole bunch of those companies have come and gone because at the time, it was like, well, you got wood, you got straw. This one's more expensive. We know this one, so we'll stick with that one. And those companies have kind of, come and gone. Hopefully now that there's sort of this climate benefit attached to it, and maybe like you're saying, also, the rise in lumber prices, because the technology is there. It's been here before. People have made these things and sold these things. It just didn't stick, and maybe this is the time that it will stick because of all of those factors.
I feel like there are a number of companies that have been out there for some time, like Blue Planet comes to mind, Biomason, Ecovative, that have been kind of on the fringes, and they're certainly making advances, and they're very active. But I don't know. Do you have any updates on what those folks are up to, and if they're gaining any momentum on any kind of scalable size?
Ecovative is backed away from building products for now, as I understand it. Maybe somebody knows more than I. I've talked to Ginger at Biomason, and they're doing great.
Yeah.
And they'll be part of our call Monday morning on mineral architecture, growing it, as well. Will Srubar at University of Colorado is developing a biological concrete in his lab. And Brent Constance, who is the founder of Blue Planet, will also be on the call. And last I heard, they're trying to secure financing to build a first plant here in the Bay Area, and actually have it on the market. They built some, and they've used some in the San Francisco airport to everybody's great satisfaction. For those who don't know, Blue Planet is a company that proposes to gather the carbon emissions from cement or power plants or any industrial plant, and basically take the carbon and, mimicking the action of an oyster with a grain of sand, roll a grain of sand around in it, and basically make artificial limestone aggregate that you use for the bulk of the concrete volume. And therefore, you're taking the emissions and directly putting them into the concrete. And Brent says we don't even need to worry about the cement anymore. We can just gather the emissions at the cement plant and put it right back into the concrete, basically, by putting it back into the aggregate. We'll see. Until they build a plant and we can see the numbers and see what the carbon footprint is and so on, you got to do the numbers. We don't know, but it does look very promising. And that's really the exciting thing. We can't just say don't use cement. I mean, okay, yeah, cement's a big part of the problem, but a lot of people have been trying for a long time to come up with alternatives to Portland cement that are as good and easy and cheap as Portland cement. And we're not there yet, but it's going to be probably more like dozens of little silver bullets rather than one big one.
And I think, any company starting out in this sector faces a pretty big barrier in terms of, how you get something, the proof of concept step is easy. It's actually pretty easy to make a building material that will work. But how you go from, okay, I've got a building material that works to, okay, all the builders out there can buy it that's a daunting path. And there's really, the way that this, this market works, especially for building materials, is like you can't sell 50 of something, you can't sell 100 of something, you have to sell 10 million of something, for it to stick. Home Depot won't touch you unless you can make 10 trillion board feet a year and they can stock it in all their stores all the time at the same price everywhere. So they're, but then, the building industry isn't used to sourcing from anywhere except, whether it's retailers or wholesalers, like major distributors. And if the major distributor won't carry your product because you don't make 10 trillion of them, there's nowhere to go. Like you're either at zero, or zero being you can sell locally to a handful of people who want to buy it from you. And there's no step between that and you're everywhere. And so it's it's not a business that I would want to be in. I can't wait to use the things that people can bring to market at scale, but that's not an easy thing to do. And it's going to take some incentives and some, maybe it's a carbon price, maybe it's, innovation funds, maybe, whatever it takes to make that happen. They're all feasible materials. They can all work at scale, but how you get them from where they are to scale that's a thorny question to have to wrestle with.
Yeah. Bruce, I talked to your friend Bronwyn out in your area for the podcast this week, and Bronwyn Barry was talking too about, and I've seen this come up a couple of times in the chat box here, is with people who code is having a difficulty time accepting some of these things. And so some of that pushback too is like, how long does it take it to get into the code to be something that could be approved so that a code official would say, yeah, okay, that's fine. That's an acceptable material, like, to move forward. And so we have this 3-year code cycle, which makes it really difficult. So it could be 10 years from the time you developed your product till you could get it something that would be approved that everyone's like, yeah, that's fine. And that's not sustainable, like you said, for some of these small manufacturers who aren't bringing it at scale who can't bring it at scale until they can get approval to bring it so that they won't get pushback on it. So, what's been your experience on, like, is code a driving factor in some of this stuff not being adopted?
You got a couple hours? I think it was E.O. Wilson who said, here's our problem, we human beings. We have Paleolithic emotions and mindset. We have medieval governance, and we have godlike technology. Governance can't possibly keep up with the technology or with a lot of other things. And having now sort of worked on both sides of that, I know governing is really hard. And I'll use our local example here as a sort of a hopeful example in response. I've been doing a lot of stuff in my county with my building official, great guy, and he read my book. And we have lunch every once in a while, and I said, Bill, we could write a building code. Concrete, it's the biggest target. It's all the embodied energy is in concrete. We could write a building code amendment, right, to limit the emission from concrete. And he goes, yeah, we could, but I'm not sure how to make it happen. And then a few weeks later, I stumbled into the right room at the right time, and this grant opportunity was available. And next thing I know, we had couple $100,000 to gather all the stakeholders that we really needed to have and start a process that was about 9 months long to write a low carbon concrete building code amendment. And there were two things that were novel about that. Number one, nowhere in the world, nobody's addressed emissions through building code yet. So that was kind of a first, and it was kind of interesting. But also, we didn't try to go to ASTM or ICC or the national or international organizations and do it. I've worked there. I've worked in ASTM. I've worked on codes. It's a hassle. It's a pain in the ass. It's dreary. And there's good things to be said about it, but that's the system we've got, and it won't change easily. It is a big ship that doesn't turn very fast, and it's dominated by entrenched industry. The money talks, and everybody else goes away. But that said, we thought, what if we did a guerrilla building code? What if we wrote something just locally, but wrote it in the language of the ICC so it could be as easily as possible adopted by somebody in Burlington, Vermont, or in Ottawa, or in Miami? And so that's what we did. And people are adopting it. So far, it's only gone across the bay to Berkeley, but I know that New York City's working on something. I've worked with them in New York State, Santa Monica. I don't know where. I'm hoping that a lot of other places, and I just haven't heard about it. But the idea here is that, yes, the building codes are a hassle, and they're very difficult to change. But the way it's structured in North America is everybody adopts this general template, the every 3 years revised International Building Code or International Residential Code. But every local jurisdiction can amend it any way they want to. Now, legally, they're inclined to, you have to state a reason why you're amending it. You can't just do it capriciously. There's a process, but it's not that hard to do. If everybody in your county decides this is what we want to have, you can just do it. Nobody tells you what kind of building code to have. So I suspect that, like so many other things, everything is going to start localizing, and that maybe we can drive building regulation locally and let it move upwards rather than, I mean, if you try to go to the ICC and try to do something really progressive, you might succeed. There's plenty of progressive people, plenty of building officials and people in that world who want to do the right thing, but it just takes a really long time. So does that answer your question? Try it in your county. If you want to look at our building code, it's a Marin County, just Google Marin County concrete code and you'll get right to it.
Sure, that answers my question.
Well, I'd like to sort of answer the question too, because one thing that happened in 2015 was that a lot of people in the U.S. did some great work to get straw bale construction into the International Residential Code. There it is. Was there suddenly an explosion of straw bale building because it was in the code? Nope. It helped the people who are already inclined to do projects like that. It was really valuable. It gave it some sort of added legitimacy. But the fact that there is now, in the US anyway, not up here, this like code approved pathway to do a straw bale building didn't drive, massive amounts of builders to start picking up straw bale. So I'm not sure that code is ever, not ever, but like it's not, I don't think it's the leader that we, kind of want it to be. It's in a lot of ways, code is a follower, with the exception of like the kinds of things that Bruce is doing. And you can, you do want to be pushing at that front for sure. But I think it's not, lots of things have come, into sort of market prevalence without being in the code first. Like I'm thinking of, foam ICF blocks, up in Canada anyway, they were an alternative compliance thing for the first, 15 years that they were on the market. And they were already a huge share of the market by the time the code was like, oh, okay, like it's, it's finally showed up in the code. It took because it gave everybody everything that they wanted, price-wise, availability-wise, performance-wise, like all of those metrics obviously worked for that product. I think marketing and marketing dollars really help. But it wasn't the fact that it was or wasn't in the code that made it, suddenly work. And I think the fact that straw bale is in the code and it hasn't taken off is, also points to that. It needs more than just the code support for it to work.
For sure. In fact, I was going to say, I think I'll let you talk in a second, Travis. I think my thought was for those of us who are trying to push it, maybe they're trying to do tiny house or they're trying to do these things, is like seeing it in there and being able to support your position is handy, I think, because then in some cases where maybe your code official is someone who doesn't understand it, you can say, hey, here it is in code. Like it's totally fine for me to be doing this. That was just my thought. Anyway.
I don't want to tip our hand because we have a code show coming up next week, right, Mike?
Yes, exactly. I was just putting that in there.
Yeah, we're talking codes next week, so I won't go into too much of a rant on this, but this is a passionate topic for me because I feel like it's one of the things that you guys challenged me to do with your book and with Mike's presentation and Jacob's 2 years before that. We have to do the most good that we can. And I realize that the commercial market is a much bigger player than us residential builders. And I realize that the commercial code is much more controlled by the lobbyists than my little HBA is pulling the strings around here. But to do the most good, which I think is our responsibility as a society, and certainly as a building science community, to do the most good, we need the support of the building code to consider life safety issues more than just uneven stair treads and tempered glass at the bottom of the stairs in the window. If we don't have clean air and water, then we're gonna die. So that's a life safety issue. It's got to get into the code, in my opinion, to force the large scale production builders' hand a little bit. Even if the local code amends it out for a few cycles, it does eventually get there. Just like I'm going to finally have people in my jurisdiction pushing for blower door tests, even though it's been in there since '09. So I'm really, really passionate about the idea of making codes the partner of the builder to help push this along. Because if we don't force that large scale production builder to make this difference, then the 12 passive houses that get built in my market this year aren't going to make the difference that we need, and we need it now.
Well said, Travis.
I will drink.
Yeah, but
That's
I
the
would,
show.
I would
That's it. Drink to that.
Cheers to that.
And I would also add two things. Number one, the residential market is a bigger construction market than the commercial market. It's the larger share of the North American construction market. It's very diffuse. There's 1,000 of every one of you for every commercial builder. But so it's very hard to penetrate. It's very hard to reach. It's very hard to affect. But there it is. It's a bigger market. And number two, it can have an effect. You can have an effect. If I don't doubt that all of you are building really cool buildings, and I invite you to think about what you can do on a bigger scale. As much of a pain in the ass as it would surely be to even try, and I can tell you. Think about leverage. Look for a point of leverage where you might be able to affect your region or your city or your state. You never know when you're going to stumble in the room and start talking to somebody and something could happen, and then be willing to go with that and do so. again, I think it's going to just take, like so many other positive things that have to happen in this world, it's going to be a groundswell. It's going to be us. It's not going to be a President Biden and a Democratic Senate and all of that.
I think a lot about that. Like, I think your point, Bruce, about the size of the sort of residential market being really big. It outweighs everything else in North America. And I think, when I was talking about, there's that sort of valley of death from somebody coming up with a product to getting it into the big box stores. We have these home builders associations. Why can't they be buying co-ops? Like, if we want, wood fiber insulation, if we want straw bale panels, if we want compressed straw board, if we want like any of these things that we would like to get our hands on, yes, it's a pain in the butt as me, as an individual builder. This is what I've done the last 25 years of my life. Go find the person making the cool material, track them down, and get this much of it shipped to me at great expense so that I can put it in a building. But if there were 25 of us in this region and we bought 25 buildings worth of this stuff, and our collective, our co-op, our home builders association actually made the markup on on that to keep itself going, then I can go down to the local warehouse that I'm a part owner of and go get the stuff that I want because it's there. And there's all kinds of ways that I think that we can intervene, even though we're small. Like, doesn't take more than 5-10 builders to be a reasonable market. Selling stuff to 2 homes doesn't make sense, but to 20, it's like there's a break-even point in there somewhere. And I think that's where I think lots of these communities that are building up around this, whether it's a passive house group or a Nessie type organization or those sorts of things, there are the people right there who all want to do this and who want to build something. Let's do it on a small scale and make it work. And that can be for local wood or all kinds of different products and different materials.
Like 475.
Big home builders are only a small fraction of the market. Most of the market is you guys. And you're well situated in New England. You have Nessie, you're better organized and more coherent and more in touch with each other than I think anywhere that I can think of. So now I'm going to do one of those things that we all love, is when somebody has a good idea of something that you should do. But here's something that you should do, is to organize yourself just the way Chris said, and let us know when you're done. Thank you.
There we go. All the local BS and Beer chapters are now the new Green Home Builders Association, right?
There we go.
There we go.
Yeah. No more NEHB. It's all BS and Beer. Matthias, those are all great, big thoughts, important things. On a more detail-oriented, what can we do to fix this problem? Bruce, last time you were on, we also had somebody from Carbon Cure. She's not on tonight, so you're free to speak freely. I'm really curious what you think, and Matthias was curious what you think about Carbon Cure, and then also post-consumer glass and concrete. Are those drops in the bucket? Are those significant? What are
Carbon Cure, and what was the other one? Post-consumer.
Post-consumer glass as aggregate in concrete.
Oh yeah. Well, Carbon Cure is great. It's a great product, and they're good people. I know all of them. The only hesitancy in my voice is that it only impacts the carbon footprint by 3, 4, maybe 5%. So that's good, because we need every bit we can get. And it's a technology that they can establish at ready-mix plants, so it's easily adapted to the infrastructure we've got and doesn't require people to change their behavior, which is, venture capitalists are always, as soon as you talk about having to change people's behaviors, they walk away. Checkbooks go back in the pockets because it's hard to change behavior. Sure. Carbon Cure doesn't require that. They set up their little thing. You have to keep it chilled and pressurized at the ready-mix plant, but they inject their magic liquid into the concrete and take the carbon footprint down. They inject carbon into the concrete. Good thing. Post-consumer use of glass seems to be kind of coming on strong now. I'm reading a lot of mainstream stuff about it. I can't even keep up with it. I ought to try harder. Chris is always telling me stuff that I didn't know. So, but I think it's a huge possibility. Also, you can grind it down really fine and use it as a pozzolan, as an augmentation or replacement for cement.
Oh, really? All right. And this might be more of a question for Chris. Paul asked, are any manufacturers required to disclose carbon impact? And I'd like to take that a little bit broader. I know you guys are involved in measuring and helping share carbon impacts, but that's a challenge I've found is as a building designer, how do I find reliable numbers? Like if I want to know what is the impact of this change, how do I find the carbon impact of that change?
Well, thanks for directing that my way, because I've been working on a calculator just to do that, and particularly aimed at sort of the residential market. A lot of the other calculator tools and life cycle assessment tools, I've worked with them, but they were built for big buildings, and the sort of the way they function and the material palettes they have and the options you can find in there don't really work so well for the residential market. So for the master's thesis that I did a few years ago, I assembled as many environmental product declarations as I could find, and then an EPD is like it's a product reporting document that follows an ISO standard, and global warming potential is one of the 7 sort of environmental factors that gets reported on. So they're pretty good, they're pretty good documents. You can pick apart, how EPDs are made, and there's always some issues with them, but by and large, you're getting very comparable numbers from sort of one product to another. But the difficulty for an individual like you or me in going and getting these EPDs is that only becomes like the first part of the work, because you get an EPD that says, 1 kilogram of steel has this many kilograms of emissions associated with it. And then you get one from a wood manufacturer that says 1 cubic meter of wood has this much emissions. And then you've got to figure out, well, if I made this building out of steel, how many kilograms would it be? And if I made the same building out of wood, how many cubic meters would it be? And then when you do all that math, then you can compare the numbers. And so our calculator sort of does that. It's doing all the comparable calculations so that, a wood for residential scale buildings, so that an ICF foundation is compared to a block foundation is compared to, they're all, of similar, they all match the same sort of specifications. And so that will be, it's being sort of beta tested. There's about 30 folks out there now who've been running buildings through it and giving us feedback, but it'll be coming out this fall through Builders for Climate Action. And I really hope, like, the whole reason I've been putting, the last, year of my life into making this thing is that we all need these numbers, and it's incredible when you finally see them, and it's really easy to do. And it's like, oh, okay, now I understand my choices, and I can, make some with, a reasonable amount of understanding of what the impacts are.
I want to add as a hopeful note that there's a new tool was launched. Microsoft funded a bunch of great people in Seattle to develop the EC3, Embodied Carbon in Construction Calculator, which is a public open source thing by which you can see the footprint of a great number of products and materials. I think it's still pretty oriented to commercial construction, but check it out. And I should also say that things are changing really fast. I've been part of a ad hoc group for the last 9 months, Rocky Mountain Institute, New Buildings Institute, Carbon Leadership Forum, working with the GSA, the General Services Administration. who is the biggest contractor in North America. They build more stuff than anybody. To develop low carbon procurement guidelines, so that when they put out a bid to build a courthouse in your local community, you have to show the footprint of your materials. We're not there yet, but it's started. Even under a Trump administration, somehow they're operating under radar. I don't know how that's happening, but and so we will be presenting draft guidelines to GSA before the end of the year, based on this really a lot of cool work with a lot of great people that Chris and I both know, and so on. So, and I see stuff at state of California. There's a lot happening. There's a lot happening everywhere, all over the world, really, to develop governance that addresses embodied carbon and pushes people to go to zero. And it's very quickly coming. Like Microsoft, they just built a huge new headquarters building, and they made it clear right from the outset 2 years ago that you're going to have to show the carbon footprint of your product, your process, your material, and that's going to be part of our evaluation of your bid. So kudos to Microsoft for taking a leadership role in that, because Bill Gates and Gates Ventures, they get it. Bill himself did a really cool little short video about embodied carbon. So the landscape is changing fast, and any manufacturer of a building product who's paying any attention knows that they're going to have to be able to publicly show their footprint, and that'll be part of their viability in the marketplace very soon. It isn't now, but it will be.
Mm-hmm. I would say too, like when we're all thinking, well, what can we do as sort of small scale builders? If any product you're either interested in or you buy regularly doesn't have an EPD, write to the manufacturer and say, if you don't have an EPD in the next 6 months, I stop buying your product. Like if we want the data, it's not that big a barrier for them to do it. And if they know that their customers want it, it's going to increase that. And the more companies do that, the better it is. Like right now in our calculator, I'll put every EPD value that I can find in that product category, but sometimes it's just one. There might be 6 manufacturers. I've got one data point. So that's what shows up in the calculator is that one. Maybe it's the same for all of them, but when you get more than one, you start to see, oh, look at this, like these guys make the same thing as these guys with half the carbon footprint, So even without switching to a whole new material, sometimes you can like better than half the carbon footprint of your plan just by knowing that this company does a better job than that company. And I think, the more of that we can get out there, the better it'll be for all of us to sort of make these decisions.
Somebody just made an interesting point in the chat box about incorporating the calculator into the design process. Is there anything that you can say, I think it's a scale thing. He said for a typical single family home, like that can be a cumbersome process. Is there anything that you can recommend to make it more streamlined?
Yeah, I mean, our calculator, it takes about 20 minutes to input basically your basic kind of building dimensions and R values in. And then the way because I'm a builder first and not a designer of software, what I wanted was not what I tend to see in softwares is I put in all my building stuff and I have to specify a lot of things up front so that I get an answer about the specific thing that I specified. What I wanted was I wanted to put the size and shape and performance of my building in and see what all my options are. So the way that we built the calculator, I say my foundation is this high and this long and this wide and this R value. And then everything that I can use to build that foundation with comes up with the carbon footprint attached. So I don't have to design one house with a whole set of materials, see the answer, go back, design it all again, see another answer. It's like, if there's 20 different materials that I can build the foundation of, there they all are with their carbon footprint for my building. Okay, I like that one. And I think, once people get used to it, it just becomes like the same way we've sort of learned to work with energy efficiency targets. Like you set a target, you say, I want either to meet code, I want to be passive house, I want Energy Star, I want, like whatever, there's a target energy use you want to set, then you just do the same thing with your carbon footprint. I want a zero net carbon building. Okay. You go to the calculator, you figure out how you do that. And just like with energy efficiency, there's trade-offs, right? I can make an energy efficiency building by using triple pane windows, or if they're too expensive, I can up the R value in my attic and, change something else, and I get the same result for less money. And so the same thing goes with the carbon footprint. Like it just becomes another factor that you balance. You decide what you want to achieve, and then sometimes the better carbon material, the lower carbon material is cheaper. So great, like that's a total default. I'll just go to that. When it's a more expensive thing, then you're like, is it worth it? Can I, hit this carbon target by changing those two things instead of this one? Or, it just becomes like that same sort of balance play that we do with buildings all the time between performance and cost and appearance and, all those other things. But, when you can actually just see the numbers right in front of you, it just makes it so much easier to make that part of how you make decisions.
Maybe this is just, as the architect in me, and as we get better with BIM and 3D modeling and everything, I just feel like, and as a HERS rater, like as this becomes so much more important, like does it get rolled into those softwares? Like I've been asking for the HERS rating stuff, like I should be able to export that out of Revit. Like these two things should just work together. Like why do they not work together? And, it's the same with the whole code cycle. Like a lot of residential people on here. So like house is a system. So why aren't all these things evaluated at the same time? Code, energy efficiency, carbon output, like boom, here you go. Like here's all this data. I feel like our tools should be getting smarter, and I would love to see that happen.
They're on their way. We're all used to the notion of big data and slogging around big data and being able to manipulate it in ways that can be very useful. It can also be horribly destructive, like we got Trump for president. But I know that Autodesk is very much thinking about this. They're thinking, they very much want to have like a little window in this corner of your screen that's giving you a whole building carbon footprint as you design the building and make choices. So
if I can get a window, if I can get a window that has like 6 million tiny little lines in it on exactly how they build it, I ought to be able to get some carbon data out of it too, right?
Yeah. I mean, the only reason that I made this calculator is because I waited 3 years for somebody else to do it. And it's probably going to be replaced by somebody with more budget and bigger software, because it's not that hard. The thing that's been lacking, when I started my master's work, I found 40 EPDs for residential building products, the first sort of pass through I did, and now my own little database is at like 600. So in the space of 4 or 5 years, like we're actually getting to the point where there is enough data to put into a software that, it'll start to happen. One of the beauties of the EC3 tool that Bruce talked about is that they are keeping their whole EPD database open source. So right now they don't have all the stuff that I would want for the residential calculator, but the next pass through, nobody has to build that database again. EC3 building transparency is making that available. Like you can just go scrape their database and pull in everything you want, and they're going to keep that up to date. And now we just have to play with the numbers on the other side. So I think like all those things that you're asking for, Emily, are not very far away.
I agree, and they just needed you to tell them that we wanted it, and so now they know. They heard it.
And in support of Chris's point, Mark Rosenbaum, who's a mechanical engineer and energy consultant in Massachusetts, has a few good comments that EC3 is cumbersome, but Chris's calculator is much more usable. Mark is beta testing it. Mark says he's been trying to get architects he consults with to not ask him about a product without sending an EPD along, so he sort of trains them to do the right thing. I think he had one more comment here, but I can't find it now anyway, just because on the recording, nobody can see the comments. So I just wanted to share that third-party validation that it really does work.
Can I just, I've been seeing, I'm trying to read the comments as they go really fast, but there has been a lot of talk about the transportation impacts as I've seen it. And I don't want to make light of the transportation part of things. It can be significant, but in all the whole building LCAs that I've been involved with, typically the impact just from manufacturing the materials is between like 70 to 80% of the whole life cycle impact. And the transportation as a whole, like not for any one material, but for a whole building, is usually slightly under 10%. So it's not as big a deal as people tend to think it is. And I don't want to say that to minimize it, that like, oh, go ahead and just ship from the side of the country everything you need. But it's not the big piece of the pie. The big piece of the pie is the actual manufacturing, like harvesting, manufacturing, like the cradle to gate impacts far outweigh all the other impacts. And so, you know, and there are all kinds of great studies at an individual product level of like, okay, I brought this thing from Europe. What did that do to the overall carbon footprint? It changes it, but it doesn't smash it. It's, you know, so I would say to people, don't panic a ton about the transportation side. You know, obviously if you can get it locally, obviously if you can minimize the transportation, that's great. But even if you cut out all the transportation emissions, you might have made a like 6 to 10% difference in your whole carbon footprint. So it's not the first place to go to do that. And I think Bruce is now going to he left because he's going to walk. He's going to deliver me a building product from California to Ontario to reduce the carbon footprint of getting it here. So I think that's where he went.
Jody had a fun question. What's been the biggest positive change of the last 20 years? And I'll add are there any lessons we can learn from that? So subjective question. What's the biggest change we've seen? Biggest positive change?
I mean, I think that I honestly think it is the availability of this data now. You know, I started asking myself the question about the carbon footprint of my buildings 15 years ago and couldn't, like, it was just, I don't know. There is one, but I can't tell what it is, to the point now where, you know, we don't have an EPD on every single product, but like I can pretty much put together a pretty clear picture of what the impact of this building will be. And that's just huge. And it even the practice of somebody like myself who's been thinking about this a lot, but when you actually see the numbers, it's like, oh, this thing that I thought was a big deal actually isn't that big a deal, and this thing that I wasn't really thinking about turns out to be a big deal. So that, you know, to me, that's such a big change. Just having access to that and being able to know what it looks like from an impact point of view.
Yeah. So I think the lesson there is, if you don't see what you want, make it, which is also how we ended up with BS and Beer and you guys here tonight, is we didn't have an online discussion group to talk about nerdy building science stuff. So we made one, and you needed a database that was easy to use. So you made one.
Yeah.
Yeah, that's good. This is sort of a combination from questions and also for my own personal input. So I think NESI members tend to be leaders in the field. BS and Beer viewers from all over the country, and Greg O'Barron is here from Australia. He has BS and Beer in Sydney, Australia. What was my question? So we tend to be leaders, but we also need to make a living and do things that are practical. So, you know, I tend to do things like double stud walls with cellulose because that's a level of going out on a limb that my market will bear. But I'd like to go to another level. I can't start building Adobe huts in Maine. It's just not going to work. But I was looking seriously at straw. I know you, Chris, do panelize. Jacob is on. He does straw. Travis O'Toole is on. He's connected with Eco Cocoon, doing panelized straw. I'm also really interested in hempcrete, specifically. I think hempcrete with in a double stud wall without sheathing seems to make a lot of sense for those of us, because we have a lot of a high percentage of people in the north doing relatively high end, but not like super duper high end. So if they can afford granite countertops, they can afford a better wall. What would you recommend? Is panelized straw the thing for somebody like me to take the next step? Is double stud with hempcrete the next step? Is building with straight up straw bales the next step?
I don't know. I would say if you're doing double stud in cellulose, if we ran that building through the calculator, that looks amazing. Like you're already doing the right thing.
Okay, cool. I don't have to change. Great.
And well, I mean, you'll get a slightly higher or more carbon storage if you did move to straw or if you did move to hempcrete, but that's where you weigh it up. If the hurdles for you doing that are too high, already by doing what you're doing, like in the modeling that I did for my thesis, to get the building model from the highest carbon emitter to being basically carbon neutral in its materials, we switched all the insulation to cellulose. We took the foam off the outside of the building and made it wood fiberboard. End of story. Like that, those two steps all the way through the building dropped the carbon footprint from really high to being, round about the zero mark. And then, obviously your cladding and stuff like that will then start to show up, and you can drive that up or down depending on what you choose. But, you're doing the right thing. And you actually don't have to do anything else. I wouldn't look at your walls. I would start to look next at what's on your roof, what are on the floors, what's on the, what are the interior walls? How about that granite countertop? Like, was that the best choice? Those kinds of things are going to start to be it. But like, if you're doing double stud cellulose, you're doing the right thing for the climate.
Okay, excellent. Well, that brings up a good point, what is the best roof? A lot of my clients want standing seam steel, but can't afford it, so we end up with asphalt. I've done wood roofs, but I don't know if that's really a viable solution. What's the lowest carbon roof we can do right now?
Well, roofing is one of the ones that's a lot of what I've been doing, looking at materials, I can kind of assume the same lifespan for most materials. Like if I'm putting insulation in a wall, the insulation's in the wall for the life of the building. Like it's not the kind of thing like, we're 25 years in, I should re-insulate a lot of that stuff, really stays. The foundation stays the foundation, the framing stays the framing, the insulation stays the insulation, all of those things. But when you get into roofing, that's when you have to start looking at timelines, right? Like actually an asphalt shingle roof has a much lower carbon footprint than a steel roof, but 5 asphalt shingle roofs that might be what you end up installing over the lifespan of that steel roof have a higher carbon footprint than the steel. So like that's when you get into, weighing these things up and, thinking about, do you want that, are you paying more attention to sort of the immediate upfront impact? Are you thinking about waste and there's more metrics than just carbon. So, I put steel on the roofs of all the buildings that we do at Endeavor, and we pay a slight embodied carbon price for that, but we get all kinds of other benefits out of it. I can collect the rainwater off it. It's going to last a long time, like all of that kind of stuff. It's recyclable at the end of its lifespan. So in that case, I'm not going to have the carbon footprint be the driving factor.
Got it.
Oh, wait, I want to jump in because for me, the biggest chapter here, and Kylie got to talk about it in our book review, but was plastics.
Yeah, I'm glad you mentioned it.
Plastics in both building materials and the fact that we don't recycle them. And sometimes when we do recycle them, which is something I'm not a big fan of, is we're not upcycling them or downcycling them into something that then can't be recycled afterwards. So like we're not recycling enough plastic. And then the plastic we are recycling is being turned into clothing that is fast fashion, that is then turned into piles and piles of stuff in other countries and landfills and stuff. Anyway, so any insight on plastic, how to get people to recycle more, how to use it more? I loved the thing about ocean plastic and how it was so degraded once it got to the ocean. So there are some great places that are trying to collect plastic before it gets to the ocean. Anyway, sorry, I'm a diver, so ocean plastic's sort of a thing.
Yeah.
Anyway, can we talk about plastic?
Yeah.
I'll bet anybody on this panel session, all 111 of you, could probably say interesting things about plastic. It's amazing stuff. Every one of you is wearing some on your body right now. You're listening to me through the benefit of plastic insulated wires, et cetera, et cetera, et cetera. It's thoroughly permeated into our lives and gives us the quality of life that we have that was unimaginable to the wealthiest people on earth 50 years ago. So, and it's a rolling fucking disaster, especially for all the little marine creatures. The big ones that we can take pictures of, and the heart-rending pictures of whales entangled in nets, but the little ones too, who are eating stuff smaller than you can see. It's a disaster. I'm guessing that most of you know this. It's just heart-rending. It's awful.
Mm-hmm.
So the question comes, there's two questions. How do we deal with all the petrochemical plastic we've already made and inject it into the system, into the bio shell? And then how do we, oh, my family of California quail just showed up. They're so much fun. How do we get all the functionality and the benefits that we get from plastic in the tens of thousands of ways that we do without wreaking devastation everywhere? I certainly don't know the answer. I mean, I don't think it's as simple as saying bioplastic, because if bioplastic doesn't degrade either, then that's not necessarily an answer. I know there's a lot of people doing a lot of work on that, and Chris and I have been talking about it. We're going to have a chapter on green chemistry, and the two main focuses will be, are we going to find a binder or family of binders we can use to glue together agricultural byproducts and hemp and everything else to do all the cool stuff we want to do, and then can we come up with an alternative to petrochemical polymers to insulate our wires and line our windows and et cetera, et cetera, et cetera. And I certainly don't know the answer. Talk about a complex situation. And it's an entrenched industry. In fact, I've read, I'm sure a lot of you have, the oil industry here in the time of the pandemic, they're not selling as much gas. People aren't driving. I'm not driving, neither are you. And so they say, okay, we'll just shift our market. We'll make more plastic. I just spent 2 days in a hospital. A false alarm for a heart attack and all that. I'm fine, thank you. But it was just jaw-dropping to see the volume of plastic that goes through a typical urban hospital. And that's what they have to do. I mean, they're trying to protect me. They're trying to protect themselves. The gloves are coming on and off, and it just goes right into a big plastic trash bag. It gets emptied 5 times a day.
Mm-hmm.
And yeah. Now, my guess is that, like with a lot of things, our savior will be with the little ones. I had a conversation we put on the last BuildWell conference, Janine Benyus came and gave a keynote. And so I got to have dinner with Janine Benyus the night before. For those who don't know biomimicry, she coined the term. She's a biologist, delightful woman. Read the book. It's a seminal book, Biomimicry.
Yeah.
And she told me the story about being advised by an indigenous elder in far north of Canada who said, when shit gets really bad, look down into the soil and ask the little ones for help. That's the repository of wisdom. So when I say we're going to be able to store carbon in the soil, I think it's going to be more than that. I have a feeling that we're going to find out from the little ones in the soil, in our own bodies, all over the place, that they know a whole lot more than we think they do. And so, for example, we'll develop mushrooms or bacteria or something that we can just dump into the landfill, and they can sort all this stuff out and eat it and turn it in. I can't imagine any other way that we might ever deal with all the crap that's in all the landfills and the oceans now. But that's all speculation on my part. I'm sure there's some great work already happening in that regard. I don't know what it is.
Interface, the carpet tile company, works with an organization, or it's an initiative called Networks. Anyway, they collect fishing line, or fishing nets rather, from large swaths of the ocean and use it to create these carpet tiles that they make. So that is something I wrote about 6 years ago. I'm not remembering the details very well, but I was so inspired by the whole process and what they've managed to accomplish on a pretty significant scale. That seems like a model. I don't know if there's anything else. I've never come across any other, endeavor along those lines. In fact, that was one of my questions, is if you had, but I don't know if you're familiar with that. But
big industry, my hat is way off to interface. Ray Anderson was such a visionary, God rest his soul.
Yeah.
And his vision carries on. It's embedded in the company DNA, and they're doing really cool stuff. They have carbon storing carpeting now.
Yeah.
And they've just done a lot of great stuff. And I know that other carpet companies have followed suit and are doing so also, but I don't keep track of that stuff, so I can't say. But interface, good on you.
Yeah.
They're trying.
That's one of the things when we were talking earlier about, bringing lots of these sort of more carbon positive materials to market. Our assumption is it's going to be like the, little innovators kind of bringing these things out and gradually growing them to scale. But, the other thing that I think we need to be asking of the larger companies is like, you've got the resources, you've got the ability, you've got the R&D budget, you've got the distribution, you do this. Like, you've been part of the problem up until now. Don't stop making foam insulation, but start making straw panels at the same time, and all of those companies have the ability. Drywall companies could be making clay plaster boards, and insulation companies could be making bio-based insulation, and and on and on and on. Like it's the innovators have done their work. We figured out how to do all of this stuff. Everybody knows what it takes. Now it just takes, the people with the actual resources and the actual factories and the actual structures to be able to take it to scale, And that's not that I, don't want any of these small innovative companies to succeed, but, and some of them will, but there are a huge number of the sort of like big players, the entrenched players who, we should be asking them to do that. And, and Interface sort of makes the case that you can at scale take these things really seriously and do a really good job of them and be a real company that actually makes money too. And I think again, if we want to have some market impact, make those demands. I got 3 more years of buying this crap from you, and if you don't have something better, I will cease to be your customer. Give them a deadline. And they won't care if it's just you, but they will care if there's 100 of you or 1,000 of you, or, however many of us there are, that will matter. And they have the ability to make those changes and to, go get into different product lines and, phase things out as they ramp other things up.
Excellent. We are coming up on our ending time. Do you want to make that your parting thoughts, Chris, or is there anything else you want to leave our audience with as a solid nugget of takeaway?
I would just recommend a slug of this once a day, maybe once a week. But that's my parting thought.
All right, excellent. Bruce, do you have any final thoughts you want people to leave with to think about this evening?
Yeah, take heart, brothers and sisters. What a fucking shitstorm going on around us. Couldn't have imagined 6 months ago.
I know.
And I know you're all going to go vote and all that, and we all hope Biden will win and we can manage a transition of power and all that. But it's not going to be the end of anything. It will hopefully be a beginning, and that would be great. But fear and anger are what Trump lives on. Don't succumb to that. Do what you can. Look around. Do what you can. This is an amazing time to be alive. I'm so amazed to be alive. I'm just amazed. And we in the building industry have the leverage to be a huge problem or to be a huge part of the solution. Look around, you'll find what you can do. Thank you all for coming, by the way. Thank you so much. I've really enjoyed this. Can we do it again next week?
Yes, please.
We clearly needed more time. If you didn't read it, pick up the book because they're going to release another one that we clearly all need to read.
Yeah, definitely.
Yes. Thank you both. Thank you to our audience, and thank you to my co-hosts. And I hope everybody has a good night.
Yeah, thank you guys for joining us.
Yeah, thanks.
Good night.
Good night.